So this chapter is about periodic properties of the elements, and I thought it would be appropriate to start with Mendeleev's notes. Now, Dmitri Mendeleev was a scientist in the middle 1800s, and his discovery of the periodic arrangement of the elements really changed sort of how chemistry was viewed as a science in the 1800s. Prior to the periodic table, chemists were not used to making predictions. It was not a thing that they did. They did reactions and maybe predicted what reactions uh, would happen, but they didn't necessarily like try to predict like what elements existed and how they were arranged. There were no theories to organize all of this stuff. And actually, Mendeleev was a chemistry teacher, and he was a professor at a university teaching his first general chemistry course. And at the time in Russia, there were no chemistry books written in Russian. And so his job, one of his jobs, was to write the chemistry book that his students would study from. So in his first year, apparently, he wrote a book, and he was able to put together a list of the elements that, by their weights. They knew the weights of the elements, and I was able to publish about, I believe, it was about the first 18 or so elements. It might have been even less than that. But then he was faced in the second year of having to sort of teach about the rest of the elements. And he didn't have any way to organize it. And so he spent a lot of his time before that year trying to just figure out how could he organize the elements so that they made some sort of sense to people. And you guys are familiar with the periodic table, but these are actually Mendeleev's notes on the periodic table. And so you'll notice a couple of things that are kind of interesting. There's a lot of calculations going on all over the periodic table. This is just the top half of it. You'll notice this is sort of the whole page, and he had many, many pages of notes like this apparently, where he's just writing and scribbling and doing calculations to try to find out what the relationships are between. One of the interesting things is down here, if you can sort of squint your eyes and take a look at it, or maybe I'll copy and zoom it here. And what Mendeleev was doing in this little section that I just blew up is he was trying to calculate the differences in masses to look for where you found gaps that were the same between elements. And he was also trying to sort of reconcile that with how these different elements reacted. So you can imagine like a two-dimensional grid with a bunch of playing cards on it. And this apparently was one of Mendeleev's favorite games. There's a card game where you have to take cards off and sort them and put them in certain orders. So you can imagine this is kind of what he was thinking. That, well, if I lay all these things out and I just sort of scrambled them around, what are the relationships between the different elements? He knew certain elements had relationships to each other. And so, for example, here's tin, right, on the periodic table, and francium. And he's looking at the difference between tin and francium and trying to see if this matches anything between other elements. Okay, so the other kind of interesting thing about his periodic table is, you notice this is lithium, sodium, potassium, rubidium, cesium, francium, right? Well, where are those on our periodic table, right? For us, that's group 1. And so as he was writing these things out, originally what he was doing is he's writing the elements horizontally and trying to figure out like, well, if I write them in this order that they are in terms of these elements all have a reactivity that was similar. And then he was looking at the differences in the numbers, like sodium to potassium, how is the mass changing? Fluorine to chlorine, how is the mass changing? In fact, this is actually where he got his original idea, is just by looking at the relationships between these elements. I visited museums in, for example, Oxford, England, and they have a history of science museum there. And you know that other people were working on these things around that same time. In fact, when Mendeleev published his periodic table, not too long after, there were a number of different publications about how the how the elements should be arranged. And so there were probably anywhere from 1 to 6 people working on trying to find out how the elements should be organized in some logical fashion. Anyways, if you go into the museum, you'll find actually blocks. Somebody had made blocks of elements and put numbers on them and then tried rearranging them to sort of see what the organization of the periodic table was just from wooden blocks. And so this all happened around 1860. 1870 is when Mendeleev finally published it, and you'll notice what he did is he arranged it horizontally. And these are called Group 1, Group 2, Group 3, 4, 5, 6, and 7. And there was a Group 8, but now in our periodic table you realize Group 8 is the noble gases, and these are actually a number of the different transition elements. It wasn't until around early 1900s, I guess, that the noble gases were actually discovered using a spectrometer. And we talked about spectrometers earlier. But yeah, the spectrometer was actually used to identify most of the noble gases, all out of a guy named, what's his first name? I don't remember his first name, but Ramsay was a scientist at University College in London. And he was collecting gas samples. I believe the first one he discovered was argon. And so that wasn't actually a group, and that actually was a kind of a problem for Mendeleev. When the noble gases were discovered, he was still alive, and he was thinking originally that they couldn't be actually elements. He thought they might be compounds because they violated his theory, right? He had this periodic arrangement had been going really good for decades, and all of a sudden somebody discovers new elements. The other thing you'll notice about this periodic table is that it doesn't have transition metals in it. I mean, it does have transition metals in it, but the transition metals are interspersed, like titanium, right, vanadium. You notice there's one missing here. There's several that are missing. There's several elements missing because they hadn't been discovered yet, right? And Mendeleev, and there were some gaps in here too. But anyways, Mendeleev predicted the properties of those elements actually more accurately than the people who discovered the elements and measured their properties, oddly enough. So, yeah, this is the periodic table from 1871. It's arranged horizontally. There's only 8 groups, right? And then he also, one of the other organizing theories is that when he did this, he looked at their valency. Their valency at that time was the number of atoms they could bond with of a certain type. So these are all the oxygen compounds, and these are all the hydrogen compounds. And you'll notice also something that's funny, right? What we would consider subscripts, like this is R2O, which would be, for example, like H2O, right? There's hydrogen. Now the 2 is actually a superscript rather than a subscript. So there's a lot of interesting things in these old periodic tables when you look at them. I even have my own copy from the 1920s. It looks very similar. But at that point, the noble gases had been discovered, and they were actually called Group 0 because up until that point, it wasn't until about 1910 that atomic numbers were discovered, like the number of protons in the nucleus. And once the atomic numbers were discovered, they realized that all these elements that were sort of in weird places in the periodic table had their own section in the periodic table. And that's when we got the transition elements. We got that big transition in the middle between the left side and the right side of the periodic tables. And because these had come first, right, these group 1 through 8 had come first, these got originally called the A group, and the transition metals got called the B group. Anyways, there's a couple of links to YouTube videos that are really fun to watch if you're interested in history. And you know, I enjoy it because I'm a chemist, but I also just like the history of science. And so these are really nice PBS specials. The second one that's down here is sort of the complete video, and this upper one's an excerpt. Is excerpts from the second one. Okay. Anyways, yes, this is what they often say. Mendeleev said when he was discovering the periodic table. He says, I saw in a dream a table where all the elements fell into place as required. Awakening, I immediately wrote it down on a piece of paper. Only in one place did a correction later seem necessary. And in fact, he had two elements that I believe it was iodine, let's see if I can find it on my period, and tellurium. And he didn't like the way iodine and tellurium were organized, and he later switched those two so that they would fit, and he ended up being correct. But the other thing Mendeleev did is he created what he calls the periodic law. And periodic law simply is if you put the atoms in order of increasing atomic number, right, atomic mass, sorry, not number, atomic mass, then certain sets of properties recur periodically. Elements with similar properties were put into the same group. Now, you know that wasn't originally true, right? This is the groups that he did. But originally they were all rows, right? And then I guess he thought better of it and put them into the groups into families. But they're put into the same group now. And then he used that pattern to organize all the elements according to their weights and their valencies, how they reacted. And then he saw gaps. And for those gaps on these four elements, scandium was one of those ones that hadn't been discovered yet. What he did was predict what the properties of those elements would be based on the properties of the elements to either side of the element and to the top and the bottom of the element. So the story that often gets told, right, is that when Mendeleev made his prediction, one of the elements was gallium, and he predicted a lot of its properties. And gallium was also called Eka aluminum, because if you look at its position on the periodic table, it's right below aluminum. Or it's below aluminum, I should say. And the people who discovered it, right, Mendeleev predicted that these are what the properties would be. These would be the oxide formulas, and the chloride, the reaction with the halogen formulas. And he also predicted its density. When when they finally discovered it, they had measured the density, and Mendeleev, even though he didn't have any of the element, a sample of the element, he told them that they should go back and remeasure it because it was wrong. And so they went back and remeasured it, and sure enough, that's when they discovered that Mendeleev was correct, and they corrected their paper, and sort of Mendeleev's periodic law became famous at that point. He became sort of a chemistry rock star of the, of the early or late 1800s, like 1890 or something like that. He became very famous. Silicon, right? Germanium, which is underneath silicon, he predicted the properties for it in terms of both its mass, its melting point, relative melting point density, and formulas of compounds that they formed with oxygen and with chlorine. So Mendeleev's predictions were in his periodic table were pretty powerful, and they sort of reorganized chemistry into being sort of a science of lots of random facts to all of a sudden a science with an underlying principle. The only difficulty was what the underlying principle wasn't known. Okay, and it turns out, right, Mendeleev's law predicted what elements' properties would be based on their position in the periodic table, but it never really explained why. And it wasn't until quantum mechanics and a scientist named Moseley, probably mentioned in the book, but a scientist named Moseley discovered the properties of the atomic number of elements. He was doing X-ray spectroscopy, and he noticed a particular line spectra for the elements that corresponded to a charge of the element's nucleus. And then when he took each element and analyzed it according to its charge, that's when we got like the transition metals. That's when we got the actual order of the elements, that the way they should be on the periodic table, which agreed with what Moseley found, right? Or Moseley's predictions agreed with what Mendeleev had predicted some 60 years earlier. Mosley also interesting side note. Mosley would have been the youngest person to die to receive the Nobel Prize in chemistry. He was about 19, but then he went to war and got shot by a sniper before he could get the Nobel Prize. And so, yeah, but they predicted that he would be the person to get it until he went to war and got killed.